you can see this on the YouTube channel. Stop talking, young man. All right, so anyway, if you see something like this, which you probably will, sine of theta n equals 1/3 and theta is in quadrant 2, find the exact value of sine of theta plus pi. So we'll just do one of them. We don't know how to do this one yet until I teach you the formula.
Can you just do C? That's the only one I need.
Just do C? Sure. Okay, so you call this like alpha and you call this like beta, right? So you know that the formula for cosine alpha minus beta is cosine alpha, it goes cosine, cosine, sine, sine, right? And if it's minus with cosine, you put a plus in it. So it's sine alpha, sine beta. And so then you just plug in cosine of theta. Oh, I guess we have to draw a little picture first, right? I'm going to try to draw a little picture of, not a very good picture, but sine of theta is 1/3, and it's in the second quadrant, so you draw a little picture for theta. Got it? And so this is angle theta in quadrant 2, and you put a 1 here and a 3 here. The sign is opposite over hypotenuse. You could also call this side 1/3 and this 1, but then you have to deal a lot more with brackets. So you do the Pythagorean theorem, and this comes out to be what? 2. It comes out to be -2 root of 2. Because it's root of 8, right? Square root of 9, or 9 minus 1 is 8, so it's square root of 8, which simplifies to 2 root of 2. But you make it negative because it's in the negative x direction. And then this angle, beta, so this is like your alpha angle, alpha, and your beta angle is, in this case, it's pi over 3, right? And so beta in this case is pi over 3. And so then cosine of alpha is cosine of alpha. Oh, alpha is theta. So cosine of cosine of alpha is negative root of 2 over 2 over 3, right? You understand what I'm doing here? Okay. Negative 2 root of 2 over 3. Cosine of beta is pi over 3. Anyone know what the cosine of pi over 3 is? 1/2. It's one of those. Sine of alpha is the sine of theta, which they give you, right? And so that is just plain old 1/3, or you can look at the picture and see that that's 1/3. And sine of beta is the sine of pi over 3, which is your root of 3 over 2, okay? And then notice that you're going to have a common denominator here, and here I just multiply this times this. 1 times anything is just itself, so you have negative 2 root of 2 over 6 plus root of 3 over 6. And I am allowed to subtract, whoops, did I mess up? No, I didn't mess up. Oh, I in the last class, I think I messed up in the last one. Oh well. They'll figure it out. So minus 2 root of 2 plus 3, the whole thing, plus root of 3. Root of 3 over 6. And that's your final answer. Right? You get that? Questions? 44. I can do 44. So 44, there we go. Take a picture of that. Let's put it up there. I just have to tell you something. I have to pause my video real quick. So let's move on, class. So this one right here says, so you're using the cosine of alpha plus beta. So the formula just like the last one, except we get a minus sign in between. simplify this. Cosine pi, cosine theta, you just leave it as theta. Minus sine pi, sine theta. And then cosine of pi is, who knows what that is? That's a -1. Very good. And times cosine of theta, you just leave that as cosine of theta. And the sine of pi is 0 times sine of theta. And what happens is this goes away. So you've now shown that this is equal to negative cosine of theta. And that's all you have to do. That's easy, right? Okay. And then let me just do 2 more problems. So the next thing that you have to know, so I didn't make a note sheet because there's only one new thing on today, and I thought that was a waste of paper. Here's all the sum and difference formulas up here. So these 2 right here are the tangent sum and difference formulas. So that's not very good. Okay, so here they are. Let's get rid of this video thing. There they are. Oh, that's too big. So these are the 2 formulas that you need to know for today, tonight's homework, and it's just another formula that you should probably commit to memory. And note, so tan alpha plus beta, so it's like tan of alpha plus tan of beta over 1 minus tan alpha tan beta, and if it's minus, and these are minus, and this is plus. Right? So let me give you an example to show you the way that that works, and then I'll do one more example, and then we'll be done. So say for instance, you want to do, oh, where's my, there it is. And you want to do the tangent of 11 pi over 12. They give you this, and they say find the exact value. Find the exact value of tangent of 11 pi over 12. So what you first want to do is break this into 2 things that you know the tangent of. Points on the unit circle, like 30, 60, 90, 45 degree angle. So you could change it into degrees, but try to play with this in terms of pi. Like I could write this as the tangent of. Anyone want to try to figure that out in terms of pi? Yes, Olivia does.
5 pi over 6 and pi.
5 pi over 6. 5 pi over 6 and pi. Let me see that. 5 pi over 6. 5 pi over 6. It'd have to be 6 pi over 6. No, she's right. Plus pi. She's exactly right. Yeah, that works. Okay. Now, what I did, I broke it into, so that's not what I was going to do. I was going to say that it was equivalent to tangent of 3 pi over 12. 3 pi over 12? No. Yeah. 3 pi over 12, just so you can see it, plus 8 pi over 12. 8 pi over 12, which is tangent of pi over 4, right? Plus 4 goes in there twice, and 4 goes in there thrice, plus 2 pi over 3. And you could do it either way. Olivia's way is fine as well. What happens though is you end up with 2 things that look very different, okay? But you could probably find a way to change one into the other. So I'm going to try to do it with Olivia's way. And so you're going to go tangent of 5 pi over 6 plus tangent, oh, this one works out. Yes, because you have fraction. That's why. Okay, I don't have to do, oh, that's just, I can show you both ways. Okay, plus tangent of pi with, what is tangent of pi? that's 0, right? Over 1 minus tangent of 5 pi over 6. Well, maybe it's not so good. Tangent of 5 pi over 6 times tangent of 5, which is 0. So this might work out kind of nice, right? So tangent of 5 pi over 6 is the same as the tangent of 150 degrees, right? So what's that? Who knows? I know. Negative root of 3 over 3. What's the tangent of 5? 0. Okay? Over 1 minus what? 0? Is that it? Is this the answer? Is it just negative root of 3 over 3? Because 5 pi over 6 is in the second quadrant, and tangent is negative in the second quadrant. No. Tangent is tangent is root of 3. Yeah, so the answer is just negative root of 3 over 3. So just for kicks, let's do this one, okay? Just to show you, hopefully it'll work out the same. So I'm going to go tangent of pi over 4. Who knows what tangent of pi over 4 is? So this is going to look like, when I do it, we'll get there. Tangent of pi over 4 plus tangent of 2 pi over 3 over 1 minus tangent of pi over 4 times tangent of 2 pi over 3. So the tangent of pi over 4, who knows that? 1. Okay? Plus, tangent of 2 pi over 3 is the same as the tangent of 120 degrees. So that's where it is negative root of 3. Yeah? Okay? Over 1 minus tangent, what does that say? Pi over 4, which is 1, right? Times negative root of 3 again. So what's nice about this is it appears twice, so you don't have to like look these things up twice. All you really need to know is two different tangents. And so this is 1 minus root of 3 over 1 plus root of 3. And I want to make it look like this. I bet I can do that. Anyone know how to make it look like that? Multiply by something. By the conjugate. Okay? So that by the conjugate of the bottom. That's how you get rid of a square root in the denominator. So I'm going to multiply by 1 minus root of 3 over 1 minus root of 3. Okay? And when I do that, I FOIL things. So I'm going to FOIL this with this. And FOIL this with this. And on the bottom, what's nice about that, I get 1 times 1, which is 1. And the plus root of 3 and the minus root of 3 disappear, right? What's root of 3 times root of 3? 3, so we get minus 3 on the bottom. 1 minus 3. On the top, you get 1 times 1 minus root of 3 times plus minus root of 3 gives you minus 2 root of 3. And negative root of 3 times negative root of 3 gives you plus 3. Okay? Plus 3. And now you combine on the top, you have 1 plus 3, which is 4, minus 2 root of 3. And then on the bottom, you have negative 2. And then, is it not going to end up being the same? And I divide, no, here's fine. 5 pi over 6 and 6 pi over 6. Oh! After all that, you don't add the denominators, right? 5 pi over. Yeah. So we messed up. Yeah, 55 pi over 12. After all that work, it's okay. So let's continue with this one. So everything we just said is wrong. So over here, this is good so far. I could go back and edit these videos, fortunately. But we just thought that this is 5 by over 6 and this is 6 by over 6, so this would be 11 by over 6, but we don't 11 by over 12, not 11 by over 6, right? But just to show you there are other ways to do it. So now if I divide both of these by -2, what happens is this turns into a -2, okay? And this cancels with that, and I get a plus plain old root of 3. And so that's your final answer. -2 plus root of 3. Or root of 3 minus 2, however you want to write it. This is probably the better way to write it. So that's okay. It showed us, it's good to see errors once in a while. Probably some of you are watching on the video channel and said, this guy's really dumb. He thinks that 5, 6 plus 1 is equal to 11, 12, which is not. Okay. So, anyway, we're making fun of me. All right. So the next one, I did want to look at one of these because I think you have one like this on your homework and I didn't quite get to it in class. So let's just look for kicks at 66. I found my kicks on problem number 66. There is a song. Isn't there a song? I found my kicks on Route 66. You ever heard that song? Get your kicks on Route 66. Well, we're going to get our kicks right here with problem 66. So that's better. All right. So anyway, so people see this on a test or in a quiz and they get very confused and they say, oh, this looks so horribly complicated. I don't have any idea how to do it. Shush. No singing. Okay? So what you want to do, this is like there's some angle. Think of this as there's some angle whose sine is square root of 3 over 2, and we'll call it alpha. And there's some angle whose cosine is 1, and we'll call it beta. Okay? Now you guys know, because you're smart, where is sine equal to square root of 3 over 2? At 6 degrees. We're just going to go in degrees. So alpha is 6 degrees. See that? And what is the angle whose cosine is 1? 0 degrees. Okay? So then what you do is you go sine of alpha plus beta, okay, which is equal to sine alpha cosine beta plus, couldn't you just what? That's a good point. Okay, cosine alpha, sine beta. And so what William just said is very correct. He said, if you already know that this is 60, right, and this is 0, you don't have to go through all this junk, right? So sine of 60 does come out to be root of 3 over 2. But if you had ones where this didn't come out to 0, then you'd have to plug into one of the formulas, which you'll have a couple of those tonight. Okay, I'm pretty much done. I'm going to show you right here what your homework is, since I'm on the cutting edge of technology, by going up here and going to Big House and going to chapter 6 and showing you that tonight's homework is right, go away. Tonight's homework is right over here. Okay? And there it is. You can see that. Okay, and that's the end. That's a lot of problems. Not that bad. Only 19 minutes.